Okay, number 10, we have to figure out if the following are parallel, coincident, or perpendicular, or neither. So parallel and coincident is the easiest thing to figure out because they're similar to each other, right? They have to have the same directions, if you will. So let's look at the lines in the first one. So line 1, oh, this one, has a direction of 2 and 1. Line 2 has a direction of -2 and -1. And what I notice about those two lines, I notice that line 1 is the negative of line 2, which means they're at least parallel, right? They're scalar multiples of each other. So the other thing I need to check is, are they actually coincident? Are they the same line? So the way to check that is take a point from your first line. So point 1, let's call that, would be the point 5, -3, and see if it actually lies on the second line. So I'm going to use the equation x equals 23 minus 2s and y equals 6 minus s, and use my point, my x and my y, and I better get the same parameter. If not, the point does not lie on the line. So x is 5, so 23 minus 2s. So I will get 2s equals 23 minus 5. 2s is 18, so s is 9. I'll try the y part. I get 6. Sorry. I get y equals 6 minus s. In other words, s equals 6 plus 3. S equals 9. Hey, I got the same parameter twice. So these lines have the same points and point in the same direction, which means they're coincident. Okay. Try part B, we're looking at planes this time. So planes are given in two different formats. One's Cartesian, one is parametric. We kind of want to compare them in the same form. So I think it's easier to change this into a normal. And we can do that by recognizing our two different directions. So we'll call it S, which would be the X would be 3, the Y would be 4, and the Z would be 3. And we'll call the other one T. We get -2, 1, and -4. And now we can figure out our normal. So our normal is S cross T. So 4, 3, 3, 4. 1, -4, -2, 1. And that's cross. So -16 minus 3. -6 minus -12. And 3 minus -8. Which gives us a total of -19, 6, and 11. So let's compare. So the first one had a normal of 1, 5, -1. 1, 5, -1. That was the first normal, right? Our second normal, normal number 2, was definitely not the same, nor is there a scalar multiple. So that tells us not parallel or coincident. That can't be possible, right? So the next thing we want to check is, well, are they perpendicular? And the easiest way to check perpendicular is taking a dot product. If they're perpendicular, then my dot product should come out to 0. So let's see. -19 times 1 is -19. 6 times 5 is 30. 11 times -1 is -11. And what do I get on the left side? Oh, I got 0. So what does that tell me? That tells me perpendicular. Now, just to point out, in case it hadn't come out that way, if it's not parallel or coincident, and it's not perpendicular, the only thing you're left with is neither, obviously.